All right, so in the last video, we talked about solving by elimination by multiplying some constant to either the top equation or bottom equation first in order to create opposite coefficients. Now, this example that's given to your notes, okay, that's provided in your notes, is a good reminder of how to go through that process. If you want to hit pause and just read through it on the video, or if you'd like to, if your notes is right out in front of you, just walk through each step. That would be a good reminder of what we did in the last video. Notice they give you these two equations here, and they suggest if I multiplied the bottom by a -2, by a -2, the -2 and the +5 here would create a +10, and then you'd have opposite coefficients, okay? So that's what we went through in that last video. So if you want to hit pause and walk through that question first, you're welcome to. Otherwise, I'm going to go down to these bottom two questions, 7 and 8. And let's talk about what happens when you can't just multiply one equation by a constant. If that's the case, if you can't multiply just one equation by a constant to create opposite coefficients, you might have to multiply both equations by some constant to create opposite coefficients. And what you're going to find, it's really not going to matter whether you're working with y or if you're working with x. You just need to pick either the x or the y to eliminate and make sure that you have opposite coefficients, okay? For instance, when I'm looking at 7, personally, I think I want to eliminate y simply because it has a negative and a positive from the get-go. We could eliminate x, that would be fine, but I'm going to shoot for y because we have a -3 and a +2. So what we need to do is multiply the top and the bottom both by some constant, and they could be different constants, they don't have to be the same, so that we create opposite coefficients, okay? So notice, if I multiplied the top by a 2, that 2 times this -3 would create a -6, right? And if I multiplied the bottom by 3, that 3 times a +2 would create a +6, and thus I'd have my opposite coefficients, okay? So let's go ahead and multiply the top by a +2. Well, 2 times a -9 would make -18x. 2 times a -3y would make a -6y. And 2 times the -9 here would give us another -18, okay? So multiplying that 2 through, this is now our new equation, okay? And it still remains equal on both sides because we multiplied the same constant to each term. Then if we multiply 3 to the bottom equation, 3 times the -5 is -15x. 3 times 2y gives us a +6y. See, notice we have our opposite coefficients now, okay? And then 3 times 6 is equal to 18, okay? So this now becomes our new equation. You might say, well, where did you pick 2 and 3 at, okay? Well, I just picked whatever number to multiply the top and the bottom by to create this, okay? So it doesn't have to be a certain number. You just got to pick some number value that would work. For us, it was just really easy to multiply. Notice when we started in the top equation, it was a -3y, and the bottom equation was 2y. They already have opposite signs. If I multiply the top by a 2, just like this is a 2, and I multiply the bottom by a 3, just like this is a 3, that's going to give us the same number. 2 times 3 is 6, and 3 times 2 is 6, but we already have a positive and a negative. So that's why I used it, okay? You can follow that same guidelines every single time, and you should be fine, okay? So now after we created our new equations, I just need to add these guys together. Well, we have a -18 and a -15. So again, when we have two negatives, we're going to add and keep the sign. So we have -18 plus a -15. And then we're going to add that together to get 33. They're both negative. Keep it as a negative. Our opposites cancel out. And then we have a -18 plus 18. Well, those are going to cancel out too because 18 minus 18 is 0, but we want to keep the 0 because we need a constant on the other side, okay? Well, now we have a -33 times x equals 0, divide by our coefficient, and we get that x is equal to 0, because 0 divided by -33 is going to give us 0. Okay, so now we have one of those, and then everything after this is still the same as what we've looked at before. I need to go back to one of these original equations, so if you need to, you can kind of erase this part. I need to go back to one of these original equations and plug this in to find y. Okay, so I'm going to plug it into the first equation we have here. okay? And I'm going to plug in 0 for our x, okay, because that's what we solved for was x. So now let's find y, okay? Well, negative 9 times 0 is 0. And again, you don't have to put the 0, but if you want to treat it like a two-step, you're more than welcome to, okay? And then we would subtract 0 from both sides. This goes away, and we get negative 3y is equal to negative 9 minus 0 is still going to be negative 9. Divide by our coefficient here, and we get y is equal to a negative and a negative make a positive. 9 divided by 3 is 3. So we get the point 0, 3. Okay, so that would be our solution. Let's try one more. Okay, so again, in this example here, it doesn't matter if we want to eliminate x, it doesn't matter if we want to eliminate y, we just need to multiply the top and the bottom. If we don't know anything else right away, we can't multiply the top by just one constant or the bottom by one constant, then we got to multiply both by a constant so that we can eliminate either x or y. Okay, now when we look at this, is there any opposite signs from the get-go? No. This is negative and this is positive, right? So that should tell you right away that we're going to end up multiplying one of these by a positive and one of these by a negative so that we can get opposite signs, okay? Well, last time, let's see, last time we eliminated, it looks like we eliminated y. Maybe this time let's eliminate x, okay? So let's multiply something to the negative 8 and something to the negative 9 here so that we can get rid of x, okay? Well, notice you can follow this same technique every single time and it will work just fine. You could just multiply the top by a 9 and the bottom by an 8, 8, 8, 9, 9, and that will always give you the same thing because you have a 9 times 8 and an 8 times 9. You're multiplying it so that you get the same value, okay? But keep in mind, one of these needs to be a negative in order for us to have opposite coefficients. So let's just make, it doesn't really matter, let's just make the bottom one a negative 8, okay? Well, now I should have opposite coefficients, okay? So let's multiply the top one first. 9 times the negative 8 makes negative 72x. 9 times 5 is going to give us a positive 45y. And then 9 times 8 is a positive 72. Okay, then we are multiplying by the bottom here, and we have a negative 8 times a negative 9. Two negatives make a positive. Negative 8 times a positive 8 makes a negative 64y. And then negative 8 times 9 gives us a negative 72. Okay, so now adding this together, notice we have our opposites now, and we can ignore all this for the moment. These opposites cancel out, and then I have a 45 and a positive 45, and we have our negative 64. Subtract and keep the sign of the larger, which is going to give us negative 19y. Adding a 72 and a negative 72 is going to give me 0. Dividing by our coefficient, this goes away, and we get y equals 0 divided by anything is 0. Okay, so we end up with our y is 0. Now we need to go back, again, to the original equation. One of the two, doesn't really matter, okay? Let's go with the bottom one. Why not? And then we're going to solve for x. So we're going to plug in 0 for our y over here and solve for x. So since I'm running out of room, I'm going to write it below. So we have negative 9x plus 8 times, plugging in 0 for y, equals 9. Well, we end up with negative 9x plus 8 times 0 is 0, so we have plus 0. You don't really need to write the plus 0. If you want to, that's fine. We could treat this like a two-step and subtract 0 over. Either way, we're going to get a negative 9x equals 9 minus 0 is what? 9. Dividing by the coefficient, a negative 9 from both sides, we get x equals 9 divided by 9 is 1, and since we have a positive divided by a negative, it would be negative 1. So our solution here would be a negative 1 for the x and 0 for the y. Okay? So on these two equations, again, if you can't think of multiplying just one number to one of the equations, then multiply both equations by some value. It doesn't have to be the same value to the top and the bottom, and it could even be a positive and a negative, just like we saw here, a positive 9 and a negative 8, so that we create opposite coefficients and then follow the same steps as normal. Okay?